Welcome. This is the technology advancements moving forward for beyond visual line of sight operations. I'm going to introduce some of our panel members here in a second, and once again, I just want to thank AUVSI and I want to thank all of you for coming out today, because I think this is going to be a good opportunity, especially on the last day, to open this up for a little bit more of a discussion. So as you're hearing our introductions, if you start to develop some questions, feel free and be ready, because hopefully about 10 or 15 minutes in, we'll open up, and if you have questions on the mic, we'll keep this more conversational. So once again, thank you. I'm Joe Morra. I'm the Director for Safety and Operation at the FAA's Unmanned Aircraft Systems Integration Office. Basically, our office works across all lines of business within the FAA and across our industry partners too, to be kind of the belly button within the FAA for all things UAS, and it's a really great place to be. I come from manned aviation, from the flight training business. My wife and I own a small flight school. So I'm an ATP, I'm a flight instructor, but I'm also a big advocate of things we've done in the past years through exemptions, waivers, deviations, all the new things coming out from the FAA. So I'm really happy to be here, and it's great to see all the focus around beyond visual line of sight right now, which there's challenges, but I'm confident that this industry here is poised and ready to go. So with that, we've got some great panel members here, and they're pushing the boundaries, and they're involved in different ways with beyond visual line of sight operations. So just to go down the line here, we have Rand Krauss. He's the CEO and co-founder of Airobotics. Then we have Paul Rigby, the CEO of Consortiq. Did I pronounce that correctly?
Yeah.
Consortiq, okay. And then we have Kevin Gallagher. He's the president and CEO of Simulyze. So you heard a little bit about me. I'm going to pass it off to Rand and let him tell you a little bit about what their company does, and we'll go down the line.
Thanks. So I'm Rand, I'm the CEO and co-founder of Airobotics. This is actually my third company in the space. I was the first licensed UAV pilot in Israel on the commercial side of things, and started the first company in Israel to provide services with drones. It was called BladeWorks. Founded another company called ParaZero that develops pyrotechnic parachutes and other safety solutions for drones. And then started Airobotics. Airobotics, claim to fame, is a completely automated drone system, no pilot in the loop, docking station drone, and essentially utilizing drones as a tool for industrial enterprises and other vectors. If you saw about a 3-ton docking station painted gray and orange on the floor, that's us. Company is about 250 people strong. We work in 5 countries, 3 continents. So Israel is our headquarters, and we also have an office in Perth in Australia. Just started an office here in Scottsdale and Phoenix, so we're coming to take over the States.
It's an impressive looking box if you haven't seen it already, so thank you, Rand. Paul?
My name's Paul Rigby. I'm from Consortiq. So we're helping organisations put drones in the sky safely. We're doing that now with what is now an AUVSI award-winning training program and our mission management software. My background before that was 10 years in air traffic control, working in both operations in some of the busiest airspace in the world, and also then air traffic control engineering, so building the systems behind the scenes that helps get all the information out to the right people at the right time. We made our move into the industry back in 2014 when I decided I needed a change from air traffic control, and we cut our teeth being the first guys ever to fly drones around the streets of central London for Kevin Costner, chasing cars around, never been done before, and we worked with the Civil Aviation Authority to achieve that before later getting more requests from Michael Bay to do stuff for Transformers 5 and film London Has Fallen to get some permissions. And we wanted to take everything we learned from that in 2014 and digitise and systemise that approach so we could democratise access to the skies and give everyone those tools and ability to incorporate what is an amazing technology and going to provide real economic potential for a lot of businesses.
All right, great. Thank you, Paul. Kevin?
Kevin from Simulyze, co-founder and president. We provide a operational intelligence platform that processes and analyzes complex event data from a large disparate set of data sources. We started developing and maturing this technology about 20 years ago. We're supporting military operations worldwide. We've been in tracking, at any one time, we're tracking 100,000 objects and processing thousands of messages a second to go build this situational awareness system. About 5 years ago, we saw similar gaps in the unmanned systems arena. We've kind of been focused in two areas. One is situational awareness, really supporting flight safety for the operators, processing lots of different data. Of course, we process the telemetry stream, but there's a lot more data that goes into being safe or beyond visual line of sight, more complex operations. You need to have all the other air traffic around you. You need to have weather information. You need airspace information. Lots of data sets have to be brought together and provided to the pilot, the operator, for effectively operating. Our second area is in traffic management. We've been supporting the NASA UTM development. We've supported each of their software builds and their demonstrations, their simulation demonstrations, as well as all the flight exercises that they've been conducting. With those builds, we support both the North Dakota and the Alaska test sites in their UTM research. Right now we're in the middle of the technical capability level 3 exercises. We're really focused on the USS and demonstrating technologies like the USS to USS communications and negotiations. We're providing the UREPs, the UAS version of PIREPs, pilot reports. We're working on UAS ID technologies and supporting public safety, supporting looking at failures of USSs and the FIMS, the Flight Information Management System, looking at failure modes and how to react to those. We're looking at the concept, the complex operations where you got multiple operations trying to coordinate and work in beyond visual line of sight, or in contingency operations, or as you start to operate, maybe if you would leave your operating volume or you head into unauthorized airspace. So we've been supporting a lot of that research and development.
Okay, and thank you. I will say this, for the FAA's perspective, it's really exciting because lots of conversations are, what is the FAA doing? And we like to have these opportunities to go back and say, well, what are we all doing together? Because I've said this before, we're not the innovators. You're all the innovators. We want to be the enablers. If you bring us things that are approvable, we want to approve them. And beyond visual line of sight, you've definitely got some thought leaders up here. So I know the spectrum of what we receive in the FAA and the questions that we get, but I wanted to kind of start with Rand a little bit here. Really, from your experience operating overseas and from your experience as an operator, what is your approach to beyond visual line of sight?
So, we've had the luxury of experiencing working with regulators around the world, so Israel and Australia among them. And I think the commonality is, BVLOS is a big word. At the end of the day, it boils down for us, what are you trying to do and how dangerous is it? And when you start breaking that into bricks, then it's more manageable than talking about big programs about drones flying over cities in different places and integrating with one another. I used to find it very helpful to lay down the fundamentals of what you're trying to do and break down the safety issues. So we were the first company in the world to get an approval to work without a pilot at all in Israel, and the first one to get approved in Australia for BVLOS as well. And our approach is this. Very simply put, I think that there's two things you need to look at. If you're looking at safety as a whole, which I think doesn't matter what you're doing, and we talked about this before, no one can judge whether the activity you're doing is more important than someone else, and then the risk factor can be measured that way. So you want to run an operation with a drone beyond visual line of sight. There's two main dangers in my mind. One is in the air, which relates to manned traffic, and the second one is on the ground. What is the dangers and possibilities for you to harm people on the ground? A side note for that is drone versus drone collision, which I don't think is relevant for the aerial perspective. It's more of a ground perspective, right? If two drones crash and then fall on the ground, they can harm someone on the ground, which is different than dealing with drone and manned vehicle collision. So if that's the way you think about it, you start breaking it down. You say, okay, I want to be working here. This is the route I want to be flying. What are the dangers that could be, as a ramification of those routes, be caused to either people on the ground or manned traffic? And then it really boils down to the mission and where you're doing the mission, right? If you're flying in the middle of the desert and it's an uncontrolled air traffic space, then how are you dealing with potential aircrafts coming in and not seeing your drone? Obviously, we want to be responsible for flying, even if, it's the pilot's responsibility as well to make sure that there's no obstacles, but we can't leave that up to him, right? So we're in charge as well. But that varies with where you're flying, right? If you're inside a controlled traffic region or you're in the middle of the desert, it makes a lot of difference to the technologies you need to use to make sure that that doesn't happen. So very relative to the site you're working in and the country you're working in, right? Some countries, like Israel, they have an aerial closure. So for us, let's say we're working in Intel in one of the biggest fabrication facilities in Israel. 5,000 people on the ground, and our drone's been flying completely automatically there for over a year with no pilots. But the Israeli Civil Aviation Authority granted us an aerial closure around Intel. So it's about 3 miles, and nobody's allowed to fly in there unless they ask the Civil Aviation Authority to come in. So that's one way to deal with incoming traffic. The second issue is what's happening on the ground, right? And that's where the risk analysis becomes interesting, because obviously not all sites are the same, so you look at a couple of aspects. The first would be, what is the density of population? Obviously flying over a facility with 5,000 people in it is not the same as flying in a completely remote location, like we're doing in the United States with the BHP site in Arizona, which is a closed mine. There's 5 people on site. So it's very different, right? And when you run risk analysis, you look at 2 parameters. One is, what is the probability of a crash? And the second, what is the probability of a fatal injury for someone on the ground, which relates to the density of population. And over that, you start implementing different technologies, because someone once said that a lethal impact is 66 joules. Now, if you break that into half mv square, and you think about a drone that's even 1 pound, that means nothing can fly. But, okay, let's implement a parachute. And this parachute will descend the aircraft at 6 meters per second. And we'll have a buzzer on that drone that once the parachute deploys and it parachutes down, it's a very strong buzzer, so anybody on the ground can hear it parachuting 50 feet above its head. So all they need to do is move aside. So it's a lot of factoring of different things. But basically, I would say it's very specific to the region you're flying in, the site you're flying in, whether it's on looking on the risks on the ground or the risks in the air. And what we do is, for every site, we just plan the entire thing from start to finish. So all of our flights are predetermined. We know exactly where we're flying all the time. And for every route, we do a very specific safety analysis of what could go wrong and what might be the risk for people on the ground or air traffic, and we just assign this to the regulator and have it approved on a site-by-site basis.
Good. Thank you very much for that. You touched on a lot of different things there that are really good, and I know it's different in different countries, but we do have parallels here. There's been some great things that have gone on in segregated airspace, in temporary flight restrictions for wildfire fighting, for example. We've approved beyond visual line of sight operations in those because, once again, you've essentially closed off the airspace to the people that pay attention to closed airspace. You haven't closed it off to people that aren't in the know, and that's a challenge of the FAA. It's a challenge of our whole culture too. But ultimately, this is going to be incremental too to get beyond visual line of sight operations going, because lots of requests that we get are, well, why don't we just have a UTM system? We'll be part of that system. We'll talk within that system. And I will say the FAA is not out there building a whole set of towers and everything else to control air traffic the way that we've done it with manned aviation in controlled airspace. We have an air traffic controller up here too that can tell you about the challenges of that. But I will ask Kevin to kind of expand on, when you're talking about the considerations, just like Rand said, it comes down to how are you going to, because beyond visual line of sight always leads into operations over people. So how are you going to ensure the safety of people and property on the ground? And how are you going to ensure that you've mitigated to the best of your ability, not hitting other air traffic or things in the air? And I say air traffic because there could be people parachuting. There could be, you know, we work with the U.S. Hang Glider and Paraglider Association. We work with all these concerned interests out there. So I think UTM is a concept, but UTM right now too has stepping stones with detect and avoid, has stepping stones with other things. So Kevin, did you want to elaborate on anything going on with that?
Sure. So we kind of break the operations into 3 conceptual phases, and then there's overlapping things. But we have we think about it in the planning phase, and then we go into the proactive operations, and then the reactive operations. And kind of in the planning, we are emphasizing that traffic management. I need to understand my airspace. I need to understand the environment I'm working in. I need to know the different classes of airspace, any of the protected airspace. I need to know what the weather is going to be. I need to know what the general traffic patterns, population density, all these different things to kind of make my safety case and to be able to plan effectively. I've got to know other operations in the area. I've got to coordinate with them and negotiate with them to try to minimize conflict. So that's all in that planning phase. In the proactive operations, I'm continuously monitoring my airspace, watching for dynamic airspace changes, watching for other aircraft or objects. I've been planning, I've watched out for obstacles, but I need to also continue to watch for that in the operations, the flight operations phase. So I need to have all that and provide that proactive planning so that I can try to optimize and increase the safety of my operations. Just like if you're driving your car, you'll go out and you'll look at where there's accidents or construction and you plan around them so you can effectively mitigate risk and improve your efficiency. And then that third phase is the reactive phase where I've got my onboard sense and avoid technologies, some of our ground-based sense and avoid technologies, where I observe things that are happening and I need to react to those and to deal with those. So kind of view it in those 3 course phases. We've been really focused on that planning and the proactive operations. Replanning the airspace. If I've got an aircraft issue, I've got to be on a visual line of sight mission. It's fairly complex in its geometry, but I've got to do a return to base. I might not actually have all the airspace reserved that I need, so we built capability to automatically generate that airspace, go coordinate that, and go get clearance for you to go fly your return to base, for example. So a lot of technologies in there that we've been working with, that we've been working in the NASA UTM technical capability of level exercises. Mentioned TCL3 is underway as we speak here. And been a lot of good research, a lot of good data gathering, a lot of good information to help define what the requirements and the needs are for those kinds of things.
Okay. And I'll throw it over to Paul again too. That how does that kind of translate into what you're doing in particular for Beyond Visual line of sight?
So we have some very interesting conversations at a very different end of the spectrum, and that's with the organisations. So they're very concerned about the risk that they might expose themselves to. So there's 3 stakeholders that I see coming together here. One is the regulator. Nobody wants to upset the regulator and get themselves in trouble. One is internal. No one wants to upset their CEO, their COO, and say, hey, why did you go and do that? Why do you expose our organisation to risk? Why is our customer now upset with us? And the third is the insurance companies. Often regulation is the absolute minimum level of what is expected, and the insurance companies will often go way above and beyond of that. So we're seeing conversations now where people are taking their drone operations and they've been doing research projects. There's probably 1 or 2 guys, there's probably 1 or 2 drones, and they've demonstrated what the value is to the business, and they're now looking to scale that up. And we've got clients that have bought 50 drones, and then there's the one person in the organisation who's the accountable manager, and that's the person that's going to have to answer to their board, to the regulator, or to the insurance company, and demonstrate why what they're doing isn't going to expose themselves to risk or litigation. And they come to us and they say, how do we do this? And this is the tools we need, and we need to have a real drive, because as you walk around the show floor, There is so much cool technology out there, cool sensors, cool platforms, lots of work on AI and analytics, but there doesn't seem to be enough focus about the initial one of the foundational blocks, like Ram mentioned, and that is how do we give organizations those tools, that software, and that technology, so they can now start discharging those responsibilities of flying beyond visual line of sight. Because until we start giving the organizations those tools and that software to do that, we will be building UTMs that will have nobody flying around in it, because people are still concerned of the risk in their organization. So, as you will know from being in flight school, that very first stepping stone to that is training. And we've seen other regulators around the world that have already got quite defined training programs. And we were asked by Tracy Lamb, the chief pilot of AUVSI, to help begin to implement some of those standards over here and drive what it might look like. And even with the Part 7, that was a great step to define what we might need from a commercial operator. But I think it would be fair to say that's the absolute entry point that we define to have the entry point of competence. What do we need to do to go above and beyond that? And we all know that we can demonstrate here right now, the pilot won't be in the loop for very long. How do we then move away from giving the pilot the competence to giving the organisation the competence? Because as someone who's a CEO of an organisation, I need to make sure I have the right policies in place, that my employees don't expose us to risk, and we've got the right employment records, we've got the right legal processes in place. And at the same time, when I start employing the use of autonomous technologies, they're going to behave like an employee as far as I'm concerned, and I don't want them causing harm out there. And I need the tools and processes to show that I'm discharging that responsibility effectively.
And all those processes make it easier for the FAA to digest, because we're a safety organization. When you hold up large manuals, when you hold up procedures and processes, we understand that world. We understand the benefits to business, but ultimately we're a safety organization. So with that, I do have some other questions here that I can go into, but I'd like to open it up as we said we'd do. You got some great people here that can help talk this topic. So anything in particular, anybody have a question they'd like to queue up? It's always hard to get the first person. All right, so I'll open it up to let some stones be thrown at the FAA here too. I think, Paul, we talked about this a little bit too, and I'd like Rand and the others to jump in a little bit. So where do you see improvement for the innovation of the regulator needing to take place, or what have you seen internationally too, where the FAA could learn or where we could do better? Paul?
So we're based out of Annapolis, Maryland, and the team out there have got a lot of aviation experience from the US Marine Corps, from air traffic, and from the regulators themselves. But with our team in the UK, we recently got invited to a conference with the regulator, and it was called Innovation in Aviation. But bottom line up front, they are there to stop bad things happening. But there's a bit of an asymmetric risk on the regulator, which is if they come up with some great ideas and we have a big explosion of great uses of technology and real economic benefits, they're not a commercial company. They won't see a leap in share price. They won't see huge PR go out. But if they say we're allowed to do something and we get it wrong, everyone will look towards the regulator and why we got it and why that was allowed to happen. But what the Civil Aviation Authority in the UK wanted to learn was, well, how do we take all these great ideas, and there's probably a ton of experience in this room right now, and actually use it to crowdsource those ideas of how do we make regulation keep pace with the innovation? How do we get that experience from people who've got the most unmanned experience and help carve that into regulations so that we're not necessarily expecting the regulator to come up with all the answers, but you can take all that industry experience, and that's why we get here every year, so we can start sharing all those ideas. Our equivalent of the administrator over there, he made a joke and he said, for the price of a free lunch, I'm going to get the world's best consultants in this room to give me all the ideas I need to know right now to form my strategy for the next 12 months. And I thought that was a great use of time. And I think the way I summed it up at the end of the day is it was like a regulatory hackathon. And we have the FAA symposium every year. Instead of talking about things on the stage, get the senior leadership team out onto tables, get them getting all those ideas together, and get them putting it on a piece of paper, and then start actioning it.
Yeah, in fact, that's why we have a booth out here right now. And we're available. Talk to us. We're looking to improve at different areas. In fact, our executive director, Earl Lawrence, was just recently with one of the heads of flight standards in Australia. out there observing some different operations going on. So we've got a lot of those relationships, and I know, Ann, you do work in Australia right now too. Do you see similarities with what's going on there, with what we're doing here, or improvements for the FAA here?
Well, I think the FAA is doing a good job in keeping their mind open to what's going out there. And I think the most important thing is taking small steps. Again, BVLOS is a big term. I mean, some people, you say BVLOS, they're thinking of Amazon delivering thousands of packages in New York City. But really, to get that started, you need to, think of what you're doing, working with the guys on the ground. So I think both in Israel and in the US and in Australia, and hopefully now in the US, we've had a really good connection with the regulators saying, guys, this is what we're doing. This is how we're analyzing. This is why we think it's okay to do it now. Tell us, what do you think? And there's this conversation going back and forth, and at some point it's, okay, you guys can roll. And then, okay, let's do the next step now. So instead of having BVLOS from a pilot on the ground in a mine, let's talk about having BVLOS from a remote operating center. And now that's the next step. Instead of biting that whole thing at once in one bite, we do it step by step. And then the risk mitigation makes more sense, and you get this credit, kind of line of credit with the regulator as well, seeing that, okay, these guys can be trusted, they know what they're doing, we're going to take baby steps side by side, and it takes time. And I think that's the way. I think the IPP is a very important step in that way. So saying, okay, we're going to choose a couple of programs, and we're going to really put our thoughts and heads and resources into enabling those applications, and I believe we're going to learn a lot from that.
Looks like we might have our first question.
Good morning, I'm Deanne Divis. I'm with the Inside Unmanned Systems magazine. I'd like the panel to discuss when they think BVLOS will be able to happen in the United States, given the infrastructure needs, the regulatory needs, especially the remote ID, and the standards and all the things that have to be proven out to actually make that work.
So I'll start off with, if you look on our website, faa.gov/UAS, there have been some waivers issued for beyond visual line of sight. There's been public aircraft operations that have been conducting beyond visual line of sight operations for years. Some of the military operations going on at higher altitudes too. So 107 being the first rule, not our last rule, actually enables that, because the rule says you need to be within visual line of sight, but that rule is subject to waiver. So just as Rand had mentioned, have we set out a set of standards of how you can do this fully across the country? No, we haven't, because it goes back to the discussion I had on a different panel. We couldn't have anticipated 2 years ago for operations over people. We've done studies and everything of kinetic energy and joules, and we've looked at it, but we chose the harder path to not be prescriptive about how you accomplish that end goal. And the result of that is, if you look on the waivers that have been issued for operations over people, one of them is so small and it's actually tethered that if it hits you, the assumption is it will hit you, and when it hits you, it won't hurt you. So that's one way to do it. Another is it's held together by magnets, and when it hits you, it dissipates the energy. So there's a waiver out there to operate over crowds of people with that. Another one is inflatable, and it's just a big beach ball with shrouded propellers. And essentially, when all fails, it comes down nice and slow. So could we have anticipated or written a prescriptive rule 2 years ago that encompassed all that? I think we probably couldn't have, because once again, you're the innovators out there. So what is your perspective, Kevin? I don't think we've gotten to you. What is your perspective for the timing of beyond visual line of sight and what you see out there right now?
That's kind of interesting. It's a complicated problem and frustrating. You want to be able to go, clearly define what you need and be able to enable those operations today. And it's an evolutionary process. There are operations going on with that, but there's still research that's going on. We've got the NASA UTM research. We've got the IPP and the UPP. So there's still some critical research that needs to be done over the next year or two. And I think some of that is really going to be necessary to help.
most of these right now, although we have some in the queue for type certification, you're dealing with things that do not have a standard type certificate. That's one way of proving reliability. The other way is operational, and the third is where you're operating in the airspace. So one of the focuses that we have really taken back with a lot of our interagency discussions is identification. Our building blocks for a UTM system are really register your aircraft, start to know about where things are in airspace, that's the LANS, low altitude authorization and notification capability, and then we put a strong emphasis, especially with our security partners, on identification. Because if you're going to have things that are have less human in the loop, but still have operational control, or you're going farther distances, fundamentally you're going to have to identify so that there will be an ability to have some tracking or knowledge of who's in that airspace. So to answer your original question, a really long panel answer, it was I think we're capable now of approving things, and I think as soon as we answer some of these harder questions and start to build this out, we will see more and more approvals. Identification will be a next big stepping stone to getting to a more unified system. But you have to realize too, our standard rulemaking process is a 2 to 3 year process in the normal realm of things.
Well, and I'm glad you said that. I was going to follow up and ask that. If the identification needs to be in place before you can do the beyond visual line of sight, which I understand to be pretty much the case, do you need a rule for identification and then a rule for beyond line of sight? Don't need one after the other. You can go pair. Talk just for a minute about the regulatory, because it is a multi-year process in the normal realm of things, and maybe there's something you could add about expedited.
So the beauty of the way we approach it, and we work across our agency partners here too, even in coordination for the integration pilot program too, we were mandated to receive input and take all these considerations into place. The statutes define our rules. So there's certain things in the statute and the law that are fundamental. You have to have an airworthy aircraft. You have to have a certificated pilot. You have to follow some operational rules, and you have to have a registered aircraft. Now, our rules emanate from those statutes. But those rules and statutes allow us to waive, exempt, authorize, deviate from what we have in our existing process. So we don't need to ultimately wait for an identification rule to get pockets of safe, approvable operations going on right now. There's ways to voluntarily do that. There's ways to layer up your operation with sensors, with notification of what's going on, with awareness of airspace, with taking information in from other systems like ADSB, from air traffic speeds, that type of thing. And I think that's part of what, Paul, your company kind of looks at the overall perspective of what your operation is going to encompass and what level you need to get at to ask for that, correct?
Absolutely. For us, we find ourselves sitting in a very middle ground where we understand the frustrations of the operator, and we're massive advocates of the technologies. We are enthusiasts of the applications. But coming from that manned aviation world, we understand how you have to get things through that regulatory process and how we can act as translators in that. But we've got tools today that we can just work to our advantage. So we've got a waiver system. So how do we systemize the approach today to that waiver system? So at the moment, everyone's gone out there probably creating their own bespoke way of satisfying what the regulator wants. But if we look at it and we say, okay, we've got the pilot, we've got the organisation, we've got the mission, and within that mission, we've got the areas to look at. Well, if the Part 107 is the entry point for a pilot, what's the next level? Because that can be our next tick in the box. And at the organisational level, if you have no safety management systems and you don't have any processes in place of how you learn from incidents and safety, well, let's give you that next step to tick in the box. And as we look at the mission side of stuff, if you're using certain platforms, we have no relationships or vested interest in any manufacturers. But if manufacturers can put out their information demonstrating how their platforms are safe, and they can make it onto this list, that's the next tick in the box. And you've suddenly created a pathway through the waiver system, or the operational safety case system it's called in the UK. And we don't need to change the rules for that. And then we can start taking the next level. So if we're now going beyond visual line of sight, what's the next level of training we'd expect? And we already know a lot of these methodologies because in the manned pilot world, you start off as a private pilot, and then you get your commercial pilot, and then you get your ATP and various ratings. And at the organisational level, we know what's expected of people and what systems we expect them to look like. So we don't need to reinvent the wheel here. We just need to make it easier and more accessible to those organisations that want to build BVLOS. And then suddenly you've got this very easy to access pathway through the system, and that will ultimately form the new rule.
And remember, these are aircraft operating in the NAS. And if you take that approach to it, our existing rules are there also. So some of the larger operations like Yamaha RMAX, I mean, that doesn't fit in 107 because the applicability of 107 is for aircraft less than 55 pounds. That's a 200-pound aircraft that's not only received exemptions from Part 91, the regular operating rules, they're using certificated pilots from Part 61, and they're also, they were the first company to be issued a agricultural operator certificate, a Part 137 certificate. So that required some exemptions also. But we have the mechanisms to make that happen, and that company is a good example. They came with over 2 million hours, flight hours of operations in Japan and other areas. And you know, when you analyze something like that, we have the mechanisms for approving right now. And I think that is kind of the culture change in the FAA too, to look at, all right, how can we get operations safely in the air now so that we can get more data, so that we can feed our rules and we can truly write performance-based rules. And some of you have heard me say this before, what is a performance-based rule? 107 is a good example. Lots of debate internally when that rule was being developed of, well, we should say that you have to be 75 feet laterally standing off, or you have to be more than 200 feet above, or for this speed it's going to be varying. And finally, the answer was, let's make it performance-based. It's a beautiful combination of two rules. It says, do not fly over a human being, and do not fly so close as to cause a hazard. So we got lots of criticism for that, but that gives the flexibility to the industry. If I'm in the backyard with my daughters and I'm operating something this big under Part 107, maybe 5 feet away from them laterally is okay. But if I was going to take something that I know some of the audience is, 100 mile an hour, fixed wing drone that's going to fly by them, 5 feet away probably is not safe. So, the rule is performance-based, and I think when you look at our waiver safety explanation guidelines too, those are not ultimately prescriptive. They're trying to get you to tell the story and go deeper and deeper. Why do you only want to operate on one side of the highway? Great example, when we asked deeper questions, it was because of prevailing winds always come from the other side, and in a catastrophic failure, things will be blown off, and that was a beautiful solution. You need to tell us those things. That helps us approve.
Thank you.
Thank you. Yes, sir.
Thanks everybody for being out there. My name is Brian McKernan and I'm Vice President of Consortiq North America. I like how you addressed the airworthiness for the aircraft. I think that's incredibly important. And the training. My question is to the see and avoid, that third concept. How do we deconflict aircraft, whether it's manned or unmanned, in the ATM? Do you see with the FAA and also with the TCL3 build, Kevin, utilizing critical infrastructure that is already in the United States, i.e. the 60,000 cell phone towers that we have, putting devices on there, whether it's ADS-B, ground-based sense and avoid, using that infrastructure in the United States to be able to build up and execute the UTM?
So I'll start with that and then hand off to Kevin. I think from the FAA's perspective, we want to enable an environment where multiple solutions could thrive. We don't want to pick a particular winner. So we're working very hard to let the innovative solutions come through and not dictate that you must do it one way. So Kevin, what are you seeing on the UTM side with NASA?
It's very similar that the approach is to have this distributed set of capabilities, trying to provide 100% surveillance of the national airspace, including all the lower altitude, Class G, all that is probably not practical or cost beneficial. Technology is changing. Internet of Things is going to enable a lot more of that, so that's beneficial and helpful. But we can't really rely on one technology or one solution. It's got to be a set of solutions, and really trying to integrate all that, whether it's cell towers or putting receivers on those and using cell communications. That's certainly great capability, but that's not going to be the only capability. So we've got to be able to have a way to bring all this together, let technology develop, and tools and capabilities that make sense for the environment you're operating in come together. And we've got to be able to bring all that together, process it, and provide it for safe operations. So it's not it can't be prescriptive. It's got to be adaptive to the technology available. That's some of the realities. It's difficult to be able to be all-knowing and all-observing of all possible UAS operations in the various airspace.
I would say also that I think that the approach here, let's say we're talking about sense and avoid, will have to be you are responsible to see other people rather than you're responsible to be seen. And the reason for that is, if you look at the manned aircraft industry, the process a pilot goes through to get an aircraft license is immense, right? And the training and the education and understanding what's going on. On the other hand, drones, you could pick one to Best Buy and fly it. So I think the consciousness of safety is different. That's why I think the technology needs to lean into you need to make sure that you're seeing everything around you, even if it's some cowboy deciding to fly a drone with nobody knowing about it and with no license. Because you can't bank on someone saying, okay, I bought a drone and now I understand I need to put a transponder on it or something. That's not going to happen. So in that case, if we look at the technology today, in my mind, image processing is not good enough, mainly because it's not fast enough, it doesn't work at night, I don't know when it will, and I don't think it will be reactive enough in terms of, if you're flying 10 meters per second and you look at the image processing technologies today, you're going to hit something before you see it. So I think the industry is going to go towards micro radars and LiDARs, which are at the moment too heavy. If you want to fly a LiDAR for sense and avoid, it's going to cost you at least, 800 grams, which means your bird needs to, as a beginning, be big enough to carry it. Plus, if you want to carry a payload over that, we're talking about a very big aircraft. So I think micro radars will definitely be the answer. I think we're probably 2 or 3 years away from seeing technology that is actually airborne and reliable enough to get us there. And hopefully as LiDARs get smaller and smaller, I think that's going to be one of the solutions as well.
And I think just to tie two things together there, I think there's going to be a range of solutions, and I think the key will be that it won't be prescriptive, it'll be performance-based. Can you see and avoid somebody else? Is that by the fact you knew that other people were there, or is that because you were so good at avoiding people because of these systems you've built? And maybe systems we don't even know exist yet because someone's working on it in a lab at some clever university somewhere. I think what the key is, though, is they've got to be interoperable. We've got to be able to share around this information in a way that's standard. We see lots of organisations coming with proprietary standards, and as an engineer and someone who's worked in air traffic control engineering, it's an absolute nightmare to try and get all that information into one system and make it accessible to other people. Nobody defined, no one was in charge of regulating the internet when it got going, but suddenly we got all the standards together that you can have different browsers, different computers, different access into that environment, and that's what allowed it to grow so quickly. And if we look at that same mentality in our world, as long as we work on the standards together, everyone can work on the technology to meet those standards. And the rules will ultimately be performance-based.
One addition, just from again, technology perspective with the drones, and we've got, you look out on the floor, tons of great capabilities, and it's only going to get bigger and more smaller and better, I guess is a better way to put it for the drones. But it'll get better and better. But one of the challenges also you're going to be operating in with general aviation aircraft, which a lot of that is not technologically advanced. So how do you can build a lot of capability on your drone, but you still have to be able to operate and interact in airspace that's being flown with general aviation aircraft, which doesn't have those same kind of technological advantages you have on your drone.
and I think we're seeing it quickly too, that for those of us that fly in the see and avoid world with our eyeballs, there's a lot of technologies out there, although they're speeding up, but I don't think the eyeball is the standard anymore. So the things you're putting on the aircraft, we're open for that type of technology because it's going to help all aviation. Aircraft certification within the FAA has been really leaning forward in their innovation too. They've done it in the manned world. They've done it with low-cost angle of attack indicators. That how do you get good technology into aircraft in a cheaper, faster way? They've done it on the air carrier side with rewrites of things. The old rules used to be your transport category aircraft had to have an exit that was bounded by a 3-inch border and it was 19 inches by 26 inches. So do I want to be climbing through a 26-inch hole? The new way of looking at it is you need to be able to demonstrate you can evacuate your aircraft in 90 seconds. So what does that mean? That means it opens it up to a whole bunch of different possibilities. If you want to have 100 ejection seats, it might not work, but we could look at something like that. So once again, that goes to the fundamentals of an identification system, a UTM or a traffic management system. How do we design our rules from what we learned from you through waivers, exemptions, partnerships through IPP, UPP, all these things. So we are open for business, and I know that was talked about in the symposium a lot.
I think that comparison to the manned system, the manned world as well, we should be careful not to think it's a perfect system. Because I heard thousands and thousands of transmissions when I was in air traffic control, where we speak to a very experienced pilot from a very experienced organisation. There is nothing wrong with the technology, but the human in the seat just didn't hear the transmission. So we don't really have a lot of the data to say that actually 1 out of every 100 of those conversations we didn't get through to the pilot. But suddenly we're looking at organisations who want to set the communication systems up and we're expecting them to be absolutely perfect. We can afford for them to drop out and for it to be absolutely safe.
So what you're proposing might not be an equal level of safety, it might be a better level of safety. And we just need to receive that in a manner that we can demonstrate it's an acceptable risk. Sir?
Good morning. Alex Barker. I'm a U.S. Coast Guard simple helicopter pilot, just getting into UAS world. So I'm curious how you see, based on what I've learned in the past week, a lot of the focus with like Lance and BVLOS tends to be in controlled airspace, or other, very specific remote areas. I'm curious how you see the integration of the two and expansion into, the class golfs, the uncontrolled, and, in my kind of unique use cases, the offshore kind of environment where you see, a fleet of fishing vessels is starting to, instead of using a Cessna flying around offshore to find the fishing areas, to start using a UAS or otherwise, and how you kind of integrate that and expand that out to your Joe pilot who's flying out in the middle of Alaska as a bush pilot that doesn't have that technology necessarily, and I guess wherewithal to connect and say, oh, hey, there's a UAS that nothing to worry about.
And I love that you brought that up because especially your experience as a helicopter pilot is unique and it's good because we talk with that industry all the time. There is a somewhat misconception out there that when you talk about Class G airspace, that it's because it's called uncontrolled airspace that it's unregulated. That's not true. It is regulated airspace, and there's rules from the time you jump off the ground. You've got separation from clouds, you've got pilot requirements, you've got right-of-way rules, all these other things that go into it. Air traffic control just doesn't necessarily provide services in that area. So the challenge of Alaska, for example, is a great one. What sensors can you demonstrate right now if you don't have an environment where everybody's in a UTM system that you can somehow see and avoid, that you can detect and avoid, that you can stay away from that aircraft, or somehow allow that aircraft to know that you're there? So Alaska is a great case of, they've pushed a lot of boundaries through the test sites, through other things, because they've got a lot of good use cases to use UAS up there. So back to what you said, it's interesting because sometimes Class G presents more complex or higher risk situations than some of our busiest airspace, because in our busiest airspace, you essentially know and you have participation from all of the participants there. Lance is a great example. You look at Lance, and that was a coordination at the local level of, okay, pixelate the airspace. If based on your traffic patterns and your flow and where the heliports are and everything else like that, if somebody were to operate a UAS or a UA, 100 feet or below in this quadrant and 50 feet below in this quadrant, would they need to communicate with you directly or get your approval directly? And that's what those maps really do. So that's the first step towards integrating into the busier airspace. But like you said, the challenge is without a UTM system, without an identification system that everybody, manned aviation and unmanned, are on the same page, you have to layer it up with these other things, operationally and technology. So
Our dream vision of the world would be where general aviation helicopters, at some level of manned aviation, participate in UTM. Then all the operators in the airspace will have a common understanding of what's supposed to be happening, what's happening in the area. I think that'll go a long way to helping that integration in the airspace, that there's not a lot of services. A lot of the work today is in UTM, where it's trying to coordinate, lots of BVLOS operations simultaneously at a drone level. But we would love to see where we have participation and start to build that constituency where manned aviation start to participate with that UTM. They would submit their plans and kind of reserve their airspace, if you will, just like a drone operator would do. So that's one of our, I'm not sure we'll get there or whatnot, but we think that would go a long way to help mitigate some of those risk factors.
Given the problem we've got and the challenge, it's my belief that we'll begin to see some innovations that will be applicable to unmanned aircraft, that then will become so cheap and accessible that they'll be retrospectively applicable to the manned world, and hence we can now start having more of a known traffic position in uncontrolled airspace, because they'll be cheap to use, and the business case or the safety case for adopting some very cheap technology to solve this problem will be quite clear.
I think there is one difference though, weight. So if you look at sensors that are cheap and good for manned aircraft, there's another challenge of threshold for the unmanned industry, which is the weight of the actual sensor. So that's from what we're experiencing. Every gram matters on our aircraft. Otherwise, I just put 4 LiDARs on it and have problem solved. But even if it was cheap enough, the problem a lot of the time is the weight.
I think you've seen that as well with AUVSI. They've done a lot of work with their transponder technology, and from what I understand it, a lot of that was in the unmanned world. It's suddenly become very accessible in the manned world, and they've retrospectively fitted it into light bulbs so that guys can have that same technology.
So I don't know if we answered your question directly, but at least we had a conversation. Thank you. I think we've got about 5 minutes left. Sorry.
Good morning, Madison Dixon with Mississippi State University. So we've mentioned the UAS IPP, the Integration Pilot Program, in passing a couple of times. So my question is more directed to you, Mr. Moore. Could you elaborate a little bit on how that IPP is going to directly advance the FAA's rulemaking procedure or guidelines for BVLOS operations? And then also, if we have a little extra time, if you wouldn't mind sharing some of your insight as to the FAA's take on the applications that they received to be part of the IPP.
So sure, I can share a little bit, but I can't steal any of the thunder of the Secretary of Transportation, who is ultimately the decision maker with the IPP. We've been working very hard behind the scenes to implement the presidential memo that directed the Secretary to select at least 5 lead applicants that would be state, local, tribal, territorial, and the team members that they would work with too. So that memo is a great example of its reinforcement from us at the White House level, and we had Ethan Klein from the White House out here on another panel with me. It's reinforcement that they want to see safe, timely integration of operations happen with UAS in a manner that hopefully keeps up pace with your innovation better. So the catch is with the IPP is it did not give us any additional authorities. It said the Secretary of Transportation will choose and the Federal Aviation will use existing exemptions, deviations, authorizations, exceptions, which I'm not quite sure what an exception is yet, but I'm interested because maybe we're going to leverage that. But in other words, we're going to use all the tools in our toolbox to work with these partners. And the beauty of that project is because there's so much discussion around preeminence of airspace and federally regulated airspace and how that relates down to the state level and the local level. What this really allows us to do is to interact with particular states, local, tribal, directly so that we can get the input directly with their concerns, and that will feed our rules and everything else. But I will tell you that there will be operations happening prior to rules being out because we will have the tools to do it through exemptions, waivers, deviations, authorizations. So it's an exciting program. And exceptions, yes. It's an exciting program because it does call out things in the webinars that we did beyond visual line of sight, operations over people, the potential for delivery, all this stuff. It mentions human transport. So it's really exciting. It's exciting that some people get a little bit afraid of it in the government, but I don't mind the focus and the deadlines because it makes us come together and it's great opportunities, especially with our security partners too, to work together and get their concerns heard. So from the perspective of the panel, did anybody have any IPP or anything that...
From an industry perspective, from our perspective, it's we're excited about it. We've partnered with a number of organizations to try to participate, and our real excitement and value in it is there's been a lot of technology development that's been happening over the last handful of years that have really progressed quite nicely. And this IPP and the UPP were kind of interested in trying to take that technology and really prove it out operationally so I can do more complex operations and multiple BVLOS. And so we think it's a great opportunity where we can take the next step and take these individual safety cases, for example, and then start to put it together in a broader fashion to get more complex and simultaneous operations tested out and underway.
And that won't stop anything else from happening either. I mean, there'll be priority given to some of these, and the Secretary said that we'll double what the President said, we'll select 10. But that still doesn't prevent anybody else that's not selected of those 10 to keep proceeding with waiver applications, exemptions, operations going on right now. So, good question. Sorry I couldn't give you more info than that. But
I've got one question before we leave. Looking 5 to 20 years from now, we're clearly going to have routine operations, BVLOS operations for small US, and typically, around the buildings, but at a low level, delivering transport packages, etc. And we're probably going to see the realization of flying cars, elevating systems, etc. And this is all clearly going to sit within the Department of Transportation's remit. But do you still think the FAA will be the right organisation to regulate it in the future?
Yes. So the issue is I take great benefit in the fact when I started flying and throughout my businesses, knowing that there's one set of guidelines, there's one set of rules from when I fly from New York to Los Angeles, and there's consistency, and there's safety that operators can fall back on because our regulations aren't so much rules, they're identifiers of hazards, and they let you know where things can go. So we do have over 50 years of aviation safety experience that we bring to the table. So I think there's no reason to start all over and forget all that, but we all realize that we need to change culturally inside the FAA too, because I'm an aviation safety inspector prior to being in policy, and it's a wonderful environment to have people come approach us rather than walking out an airport and hearing doors kind of close and planes being pushed into hangars sometimes, because that was sometimes a perception of an inspector coming out of the airport. So yes, I think as long as everybody will have us, we're going to be ingrained into this.
That's my only fear, but other than that, I think it's going to teach us a lot.
Yeah, please, all of you are the best ambassadors for this because you're the preeminent safety, advocates out there, and AUVSI and everything that's going on right now. Please take this out and go multiply the message and try to get people on board. And I really want to thank the panel members, and I really want to thank everybody here for, like I said, sticking it out on the last day, having a good discussion, and thank you.